If a and b are fixed numbers, find parametric equations for the curve that consist of all possible positions of the point P in the figure. Use the angle theta as the parameter, and then eliminate the parameter and identify the curve. So if we take a look at the angle theta here, okay, so we have this angle theta at center O. So here's our center O, here's our angle theta. We have this value that represents B and this value that represents A. And then if you look here, we see that this blue line represents the radius of the circle, and then we have a small right triangle here. But we want to be able to use the angle theta as the parameter. In order to do that, we need to extend this line down a little further. Okay, and so that's going to create a right triangle here that's going to include theta. So we can call this Q. So we're going to go from P to Q. And now we also need to look at this segment that starts here and it goes down here. And so therefore that's going to be comparable to PQ. So we can call this S and then we can call this T to represent a line segment that is comparable to PQ. So according to this big right triangle, we can see that the length here of OQ represents X. So we can call X, and that's going to be the line segment of OQ. And so Y represents the distance from P to Q. And if you look at the smaller triangle here, okay, this is representing the side ST, so this also equals the segment or the line ST. Now, if you look here, that this represents the radius of B, so the radius here is B. And then if we look at the larger triangle, and we can call that's in red here, we can see that the radius is A. So using the definitions of the trig functions and the right triangle, we know that for theta, X is going to equal A times the cosine of theta. And then for the smaller triangle, we know that Y is going to represent B times the sine of theta. So that is step number 1. Now for step number 2, we want to solve for theta by eliminating theta as a parameter. So if we have A times the cosine of theta, and that's equal to X, to solve for the cosine of theta, we'd have to divide both sides by A. So we have the cosine of theta, which is equal to X over A. And likewise, we're going to do that over here. We have B times the sine of theta, which is equal to Y. Now if we divide both sides by B, then we get the sine of theta, which is equal to Y over B. Now we want to use our trig identities, and that trig identity of cosine squared of theta plus the sine squared of theta, we know is equal to 1. So we can replace cosine of theta from what we found in step number 2 to be X over A, and then square that because we want to eliminate the parameter of theta. And then over here, the sine of theta is going to be Y over B squared, and then that's going to equal 1. Now if we square that out, we get X squared over A squared plus Y squared over B squared, and that's equal to 1. And what this represents is an ellipse.